Today we're going to learn about data engineering, what are their roles, and how to start and become an expert. Before starting our topic, don't forget to subscribe our channel and hit the bell icon for more updates. Let's get started. As data engineering is a rapidly growing field that plays a crucial role in managing, storing, and processing large amounts of data for businesses and organizations continue to rely on data-driven insights, the need for skilled data engineers has never been greater. Join us as we explore the world of data engineering and uncover the skills and tools required to thrive in this exciting field. Let's dive into data engineering for absolute beginners. Firstly, let's take a look about topics that we're going to cover for this videos. These are the topics we'll cover for today's video. Data engineering introduction, data architecture and management, followed by data pipelines and data airflow, tools and technologies we use for data engineering, some real-world examples and their use cases, future of data engineering, and, finally, conclusion on data engineering and some tips to learn like where to start the journey. First, we're going to talking about introduction to data engineering. What is data engineering? Firstly, can anyone guess why data engineers are so useful for most of the big giant companies like Walmart, Bank of America, Apple, Twitter, LinkedIn, and so on? Comment down your answers and let's see who knows better. Well, data engineers are first step in most of the companies for the process of transforming raw data into usable information for various purposes. The main goal of data engineering is to make data more accessible, reliable, and actionable for decision-making purposes. It involves a set of techniques and tools used to extract, transform, and load ETL data from various sources into a format that can be easily analyzed and used by data analysts and data scientists. As data engineering plays a critical role in enabling organizations to harness the power of data and use it to gain a competitive advantage in today's data-driven world. Next, we are learning about some data architecture that's useful for data engineering. Data architecture in data engineering refers to the overall design of a data system, including its structure, organization, and components. It encompasses the processes, policies, and standards for managing data throughout its life cycle, from collection to storage, processing, and analysis. Data architecture ensures that data is accurate, consistent, and accessible to users in a timely manner. It also involves choosing the appropriate technologies, tools, and platforms to support data processing, storage, and retrieval. In essence, data architecture is a critical component of data engineering that helps organizations effectively manage and leverage their data assets for strategic decision-making. In data architecture, we have data modeling, data integration, data warehousing, data governance. As we are going through some session in future, you'll get more clarity about each data architecture in the future. Data modeling is nothing about to ensure data is organized or not. Followed by data integration is combining data from different source and sets into a valid and unified data set. On the other hand, data warehousing is about design and implementation for reporting and analysis, whereas data governance is all about policies, procedures, and standards throughout its life cycle. With data architecture, we also have data management, which is mastering the data like identifying and managing critical data elements. Big data, processing into insight and value them. Cloud data is about security, scalability, and accessibility data into cloud-based environment. Overall, about data architecture and data management is critical to achieve organizational goals and gaining insights from data. Our most important topic to learn about is to know how data pipelines works, what's important of data workflow and ally of the data integration. We're going to know more about these topics in next upcoming data engineering series, as we came across what is data engineering and what's our architecture and data management. Next, we are knowing about data pipeline, data workflow, and data integration, which is useful topic to learn as to become data engineering. A data pipeline is a series of processes that extract, transform, and load ETL data from various sources into a destination, such as a data warehouse, data lake, or database. A well-designed data pipeline ensures that data is accurate, reliable, and timely, and enables organizations to make informed decisions based on insights derived from their data. Whereas on the other side, which is important to know how data workflow works. It is the process of designing and implementing a series of steps that enable the efficient processing and analysis of data, which means a well-designed data workflow is essential for organizations to extract value from their data, as it ensures that data is properly collected, processed, and analyzed. By having a clearly defined data workflow, organizations can save time and resources by automating routine data tasks, reduce errors and inconsistencies in data processing, and make more informed decisions based on insights derived from their data. Overview on data integration, which is far most importance in data engineering. The goal of data integration is to create a comprehensive, accurate, and consistent view of an organization's data. It is the process of combining data from different sources and consolidating it into a unified view, often in a data warehouse or data lake. Data integration is important because organizations today collect data from a variety of sources, including databases, applications, and third-party services. Without data integration, data may be incomplete, inconsistent, or duplicated, which can lead to errors and inaccuracies in analysis and decision-making. Next to learn is all about tools and technologies that we use in a role of data engineering. It is most important to know that these tools and technologies are far most, and if you keep on practicing it, make easier to understand on these technologies. Ongoing forward we have few tools and technologies. Firstly, Apache Hadoop. It is used for processing big data that provides distributed storage and processing of large datasets. Apache Kafka, which is distributed streaming platform used for building real-time data pipelines and streaming applications. Apache Spark, a fast and general-purpose distributed computing system used for processing large datasets. Apache Airflow, an open-source platform used to programmatically author, schedule, and monitor workflows. SQL databases, relational databases that use structured query language, SQL, to manage and retrieve data. NoSQL databases, non-relational databases that can handle unstructured and semi-structured data and do not require a fixed schema. Python libraries, various libraries in Python programming language used for data processing, analysis, and visualization such as NumPy, Pandas, Matplotlib, and scikit-learn. Cloud services, services provided by cloud platforms such as Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, GCP, for storing, processing, and analyzing data. Google BigQuery, a cloud-based data warehousing and analytics platform used to process and analyze large datasets. Apache. Cassandra, a distributed NoSQL database management system designed for handling large amounts of data across multiple servers. Talend. It is optional to learn, and with Talend, data integration and management platform that allows organizations to integrate, transform, and manage their data across various sources and targets. Apache Flink. Optional to learn, and it is a distributed processing engine for streaming and batch data that supports a wide range of data sources and processing models. Here, we have some real-time examples and their uses cases. So far, we got to know about data engineering, roles and tools, and how big companies needs them. Now we're going to set examples for company needs in real-time experiences. There are some companies with most paid salaries for data engineers for protecting and managing their data, such as companies like Walmart, Twitter, LinkedIn, Amazon. Valued banking sectors like Citibank, Goldman Sachs, and so on are real-time users. For examples, Twitter, LinkedIn, Meta, YouTube Inc. use streaming data processing to help process and store efficiently in real time. Another examples like Amazon and Walmart uses data warehousing techniques to store and analyze large amounts of data. Whereas with companies in financial sectors like Goldman Sachs, Bank of America, and other banks use data engineering to detect fraud and prevent financial crimes. So, by knowing all of these, what's the future of data engineering? As per my knowledge, it's whooping technology in the industry for next 15 to 20 years. It's going to be in a position where no one can make it down. And so far, I've seen the demand for skilled professionals in big data or data engineering who can manage and process data continues to increase. With the growth of big data, cloud computing, and artificial intelligence, data engineering will continue to play a vital role in transforming raw data into valuable insights that can drive business decisions. What do you think? Comment down below. As we came to end of the video, which is conclusion, as far as we covered the definition of data engineering and its importance, and some examples of real-world applications. We also discussed some popular tools and technologies used in data engineering, including Hadoop, Spark, and Kafka. Let's recap some key takeaways that are covered in this video. 1. We talked about data engineering involves the design, development, and maintenance of data systems that support data-driven decision-making. 2. Next, we learned about to understand a successful data engineering project requires collaboration with other teams, such as data science and analytics. 3. Also, there are some essential skills for data engineers include data modeling, ETL development, and data quality management. Tips for learning data engineering in an easy way include taking online courses, joining online communities, and working on personal projects. To get started, I personally recommended to learn basic SQL, Python, and tools like Apache Spark or Hadoop. These technologies will form the foundation of your data engineering skill set. With the right tools, technologies, and learning resources, anyone can become a successful data engineer. In the next video, we're going to learn about languages and tools that are required to become a data engineer for absolute beginners. Thanks for watching our video. Don't forget to subscribe our channel and hit on bell icon for daily updates. This is Mike, a Code Cult tutor. See you in the next video, signing off.